This is my demonstration of the code hot loading feature in the Gunship game engine. Gunship is a game engine slash game framework that I'm working on. It's programmed in the Rust programming language. It's very early on in development and it's kind of light on features at this point, but one of the things that I have been able to get in very early on is a code hot loading feature that allows me to edit code while the game is running and immediately see those changes reflected in the running game. So to start with the demonstration, I want to just quickly talk about how I have to lay out the setup of my project in order to make this feature fairly ergonomic to use. So normally if you're working on a project in Rust, you do cargo run from the project directory to be able to start your project. Cargo is the build and package manager that ships with the Rust programming language. So that's normally the way they would use to do it. You can actually use external scripts, like you could use make or any other script or any other build system that supports Rust, because the Rust compiler can just be invoked directly the same way that the C or C++ compiler could be. So normally you do cargo build to build your project, and that would compile it for you. Oh, it looks like I've got a compile error. Compile error. Well, I'll fix that in a second. But so normally you've got do cargo build to build and cargo run to run. We'll actually see that if I do cargo run on my project, it says that there's no executable. And let me explain why that is. So if I go to the cargo manifest for the project, you'll see that I actually define my game's code as a library. And I specify that it's compiled both as a dynamic library, which is a DLL on Windows, and an rlib, which is just a Rust static library. And then it depends directly on Gunship, and as well as this loader library. This loader library is what provides the hot loading functionality, and the way that you use it is for your game, you define two actual executables. The first executable runs your game statically, so that would compile against that static rlib and then be executed statically. And all it does is it links directly against your game's code, and you can just call into your game's code as you would normally. So in my case, I actually wrote the real main function for my game here in this do main, and that creates an instance of the Gunship engine, initializes the engine, and then starts the game loop. For hot loading, you create a second executable that actually does not link against your game code. Instead, it loads up the loader directly, and then what you do is you give it the loader the path to the DLL. So when you run cargo, cargo puts your executables inside of this target folder. And then it'll be like target debug, target release, target profile. So in my case, it's target/debug. And then we'll see that this is where it drops fps.dll. And that file is named fps.dll because the library name is fps, as I've specified in the manifest. So this, having the users pass in their, allowing them to pass in the path for their game particularly, means that the loader can just be reused for a bunch of different games, and the game doesn't have to always be called game.dll or gunshipgame.dll or whatever, which is actually something that I had initially, which was a bad choice. So once you've got, so since I've got this set up with the two executables, the way that I actually have to run this is you do cargo run, and you tell it that you're running a specific executable, and in this case it's called hotload because the file is called hotload.rs. And if I hit enter, it'll now give me those compile errors that I saw before. And let me actually do grid collision.rs, and that's because I tried to suppress a warning by renaming a variable, and then it actually broke stuff because I'm a little bit dumb. But why don't we clear that? And so we'll do again cargo run bin hotload, and with if you're not familiar with Rust, with cargo, if you try to run your executable, it will automatically recompile it for you if it's out of date. So we give that a second to start running. And there we go. So the game pops up. And so I've got my little first-person shooter example that I've built. And oh dear, I seem to have left a little bit of debug code in the game. So I've got some debug code here that draws this grid. And this is what I'm using to test the grid collision system that I'm building currently. But I don't need that right now. That's all deep inside the engine layer, and I'm testing that through engine-specific examples. So that doesn't really affect the game code at all. And really, it's just a little bit annoying and kind of clutters up my view. So what I can do is if I go back in here and I open up that gridcollision.rs file, the code that draws that grid is right here. Actually, there's a little, you can see there's a little demonstration of the debug drawing functionality that I've also started building into Rust, where you can just like logging, you can, from any point in code, start drawing visualizations in the game. But I don't want that right now, so I'm going to comment that out. And then what I need to do is, so I've got the game running from this command line right here. I've actually got to go to another command line, and I've got to rebuild the game. So if I do cargo build without specifying a binary, it'll actually just rebuild the library, both the static library and the DLL. And so if I let it load up and do its compilation thing, actually I'll focus on this one, and so we can see we have the game going on. I'm shooting bullets, and there we go. It just disappeared, and nothing in the game changed. Everything's left exactly where it was. And you can see that I got a little message here, this copy results and warning, cloning the alarm manager doesn't work. Yeah, so I got a little message when the code reloaded, but so everything stayed in place. The code reloaded just fine. And one thing that you'll notice about the changes I just made is this change is actually within the engine layer of the game. Like I just made a change to Gunship itself, not to any of my game code, and hotloading worked just fine. And that's something that I did pretty deliberately when I designed, or when I started working on this hotloading feature. Is I knew I didn't want to limit you to just being able to reload game code and have the engine be static, because one of the advantages of Gunship is hopefully it's pretty small. It's easy enough for you to just make an entire copy of the engine code and tweak the engine to work better with the specific details of your game. So being able to hotload engine code on top of game code is useful for developers of games, because you now have the entirety of Gunship and your game available to tweak at runtime without having to shut down the game, wait for compilation, and wait to start the game back up. And it's also just, for my own selfish reasons, it's much easier for me to work on Gunship, because I can constantly be tweaking and adding things to the game, and I have to restart, or I can constantly be tweaking and making changes to engine code, and I have to restart the game much less frequently, so it makes development for me a little bit easier. So I want to also show an example of making some changes from the game code side. So in here, I've got this little first-person shooter example, and I can shoot these bullets, but eventually, there we go, I ran out of ammo. And that's a little bit annoying from a debugging perspective if all I want to do is shoot, shoot some bullets and mess around for a little bit. So what I can actually do is if I go to gun.rs, I've got two functions in here that are relevant. I can actually collapse this down, go into impl-gun. So I've got right here the check that it makes where you can fire. And this is called by other code elsewhere. So I'll just say, yes, you can always fire. And then the other thing I need to do is, this is actually just a implementation detail, but I just need to comment that out. And then why don't I actually show you something really cool? So I've made my changes. I'm just going to save that. I'm not going to go ahead and manually compile anything. I'm just going to save that. I'm going to pull up the output for my game. And oh, you'll see that right here at the bottom, it says that it reloaded. And sure enough, even though I'm out of ammo, I can just shoot as much as I want. And the reason why this works is actually not anything that I'm doing specifically within Gunship. It actually has to do with the editor that I'm using and some of the plugins that I have. This editor is the Atom editor built by the GitHub team or some sub-team at GitHub. And one of the plugins that I have is a linter for Rust. And what that'll do is, you can see down here it says I have no issues, but if I were to do something dumb like this and put in junk, you'll see it pops up some warnings. So it gives you, your usual workflow with an IDE where you get immediate feedback when you type in invalid code. So if I type in a mistake, it'll do it. And the way this works is it just compiles your code automatically in the background and then takes the output from the compiler and gives it back to you and highlights your code, gives you a list of all the errors that you have. And because this linter plugin is automatically compiling my game's code in the background, I can just make changes to my code as much as I want. And every time I save and it successfully recompiles, the changes automatically show up for me within the game. But you'll notice that if I make a change and I save the file and there's a compile error, the game didn't crash. It fails to build, but because of the way that the loader is set up, it doesn't cause any problems with the running instance of the game. And as soon as I save, you'll see that it recompiles successfully, and eventually it'll spit out that little message that says that it was able to recompile. And so that's about it. This is a pretty cool system, the way that I've got it implemented. But as it stands, it's actually fairly limited. If you make any changes to code or to data, so say I've got my gun struct, and if I were to add another thing, let's see, like is broken bool, and then we do gun new. You can see already that the linter is really useful because almost immediately I got feedback on some changes. Is broken false, and we give that a save. And wait for that to finish compiling. We should see, oh, that's very surprising. I expected that to crash. Well, my point is, it's not, as it stands, it's not robust to changes like that, to changes to data. Normally, that actually will cause a seg fault and crash the game. That's not really a permanent limitation. That's just this is a very quick implementation of the hot loading feature. Future iterations on it will give you much more robust, potentially very robust support for making changes to data within your code, to changing things within the game when you do the reload. So say when you do the reload, you actually want to reset certain things, you should be able to do that when the reload happens. But that's it for this demonstration. I'm going to include in the comments to this video a link to a blog post that I'm writing that explains in detail how this feature is implemented, what the limitations of this feature are, and how I'll be able to solve those limitations in the future. Thanks for watching, and I will see you next time.